So hello everyone. Today I'm happy to introduce to you Tom Georgin. I don't know if I pronounce well, sorry. He is a member of Shiro Games, a famous French studio that brought to us Evoland, War Tales, Nordgard, and now work on Dune Spice Wars. He is a gameplay developer, a gameplay programmer, sorry, at Shiro Games, a studio which uses a special programming language, Haxe, as well as their own game engine, Haxe. Today he will talk about the high A of Dune Spice Wars, their 4X RTS game. So I let you continue now.
Thank you very much. Thank you for having me. So he already presented me, but my name is Tom. I'm a gameplay programmer for Shiro Games, working on the new game Dune that's still in early access. Maybe some of you have played it. A little bit of a long title, but we'll get to it. Short summary of what I'm going to be talking about. Quick slides on who I am, what I've done before, what the game is. Probably some of you at least don't know what it is. The different tools and language that we use to create the game, it's, as he mentioned, it's kind of special because it's a language that not that many studios use. Why did we need an AI in the first place, and how we decided to go at it, and then get into the real gips of it, of why is it data-driven, why is it cheatless, or at least tries to be, and that screen decided to turn off. Great. Oh, that's fine. It got restored. So as I said, I've been working as a gameplay programmer for something like 6 years now, maybe a little less. Started in Don't Nod in Paris. I've worked on a few games there. Vampire, Tell Me Why, which is a narrative game. And the recently announced Banishers. Some of you have maybe seen the trailer. And then moved to Bordeaux and started working at Shiro Games as a gameplay programmer, on the game Dune Spice Wars, which at the time was in the very early stages. So I had the chance to work on a lot of the features on it and kind of steer the game where we wanted. So just a quick video on what the game actually is, so that most of you can see what it is. That's the gameplay trailer we released.
This is Arrakis, a world of sand and death, brimming with terrible dangers, only matched by the resources and secrets it holds. Of these resources, none is more precious and coveted than the spice. But whatever you hope you'll find here, you cannot be prepared for what's waiting for you. First, you'll need to survive. Then, try to understand the land. Rally local villages or force them into submission. Use them as outposts to develop your infrastructure. And set up the vital spice harvesting process. Then build a solid foothold to start your conquest. You will have to fight to defend what you have and take what you need. Or rely on your cunning to achieve your goals through the arts of subterfuge, politics, or diplomacy.
Arrakis is mine.
But no matter who you conquer, manipulate, or destroy, you will never truly control Dune.
Okay, so you might have guessed from the video, it's actually a mix between two genres that are pretty known. 4X, which is like Civilization, Stellaris, all those really big games that usually last a really long time, usually turn by turn. But it's also a mix with the RTS genre, which is real-time strategy games, such as StarCraft. We decided to make a mix of all those two genres and create a new game that's sort of a hybrid, because it's a lot of 4X elements in real time. So you have the combat that's in real time, the politics, the spying, everything. You can play up to 4 factions on a single map. Right now the game has 5. And obviously, why do we need an AI? Because anyone who launches the game and is going to end up playing alone will be playing against 3 different AI opponents. The tools we used, I'm not going to go into details on that. That's why I put links, but you can search for it online. The language is called Haxe. It's actually a language created by one of the 2 founders of the company, Nicolas Canas. It's a high-level language, basically really nice for scripting, for example. I've put up a few examples of games that were made using that language. Hips is the game engine we use. Same thing, I've put up a few examples. Most of them are from studios created by Nicolas. But every single game done by Shiro Games is actually done using that. And CastleDB, we call it CDB, the database we use is for everything related to the gameplay of the game. We don't have like a scene you open up on Unity or Unreal Engine and you place objects. We program basically everything dynamically, at least on Dune. And all of the gameplay elements are actually inside the database. It looks like this for us. So that's like the units. So we describe everything, like the stats, the models, the names, anything. I've put up a few screenshots of the game just so you can see what it looks like for a player, and so I have time to talk about random stuff. So why did we need an AI? I've already answered that, but now that we know we need one, how did we want to make it? And there are a few things that are pretty important to us. First of all, the AI, you could think about it as just something that needs to be perfect and work in every way. But that's not realistic, and it's probably not even fun for the player, because if the AI is too good, the player is never going to have any room, so it's going to be uninteresting. It needs to adapt pretty well, because the game, we iterate a lot on the content and on the game mechanics, so we need to have an AI that at least can play even if the game changes a little, so we need to find clever ways to make that happen. Same thing, robust to future game changes. So one of the examples is like the designers decide to add a new building into the game that you can build in the villages. Can the AI build it? Well, most of the time, yes, just because it looks at the database of all the buildings and is able to pick one in there. But should the AI build that building, if you build something that's like a missile battery that's going to be attacking units and you put it on the village that's like furthest away from anyone, it's kind of pointless. So you actually waste resources, so you shouldn't. So we need to find ways to explain it, like the rules and stuff. And of course, what impact it's gonna have, like, does it cost a lot of money? Does it have like a really high upkeep or anything? Some of the goals that are important to me, at least, we decided to go with no cheating. Of course, we did have to make some exceptions, at least for now, but the goal is to not make it cheat, which is really important to me. Data-driven, that is because, as you've seen, we work with the database and the designers can change everything on the fly. So we need to have a way to give as much tools as we can to the designers so that they can modify everything. Minimalist, that's one thing because the teams at Shiro Games are pretty small. So we do need to make something that's not over-engineered and needs 5 people full-time. Just to give you a little scope, the AI of the game, I was the only programmer on it, working with some designers, and I didn't work on it full-time. And in total, I've probably spent like a year or something over a period of like a year and a half. So it needs to be simple and small. And reactive, not proactive, that's maybe something that became true, and maybe it wasn't an intention at first, but I've put up a little example of that. A proactive AI would be like, what am I? I've decided to play economically, so then I need more salary, which is like the gold of the game. To do that, I can build a processing plant which produces more salary, so that's perfect. Oh, but I'm missing plascrete to build it, which is another resource. Then I'm going to need to build a plascrete factory. And this creates like a plan for the AI it's going to try to make every step work one by one to achieve the initial goal of making more salary. But we didn't want that. We wanted the AI to be reactive and just every second it's able to make a decision that makes sense without having a long plan. So the example is kind of the same, but all the other way around. Basically, it's like, I want to build something, but I don't know what. And so it's going to look at its type. It's going to say, maybe since I'm economic, I should be building a processing plant. Oh, but then I'm missing plascrete, so it's going to fail and return. And the next time, maybe it's going to try to build something else, which is, oh, I'm low on plascrete. How about trying to build a plascrete factory? But the two are actually unrelated. Like, it's not going to build a plascrete factory in order to build a processing plant. It's just going to happen that way, organically, you could say. A few existing solutions that are somewhat famous, maybe some of you know about it. It's GOAP, goal-oriented action planning. That's really good for actually proactive AIs. Some of the games use them. Problem is, as I've mentioned, we wanted a reactive model. We ended up realizing that in the game, you don't have that many options as to actions. So you can basically just build buildings and capture territory and maybe sometimes trade with other players. But you don't have like variety in the actions that you take. The game's depth comes from something else. Also, those ARs are very stateful. That means it needs to store a lot of context and save it and use it as it goes. We wanted the AI and basically as many systems as possible in the game to just be able to, like, you can enable the AI after playing 1 hour on the game as a player, and it's going to be able to play. It doesn't need to store anything. And yeah, the goals, same thing. It's related. Not going to spend too much time because we didn't actually use that, but little mention for the neural networks. Obviously, you think of a game that has tons of different complex ways to play and interactions and everything. You're like, maybe we should build a neural network and let it do its thing. Problem is, the game changes too much. It's really compute heavy to train. And since we change the game all the time, we need to train it all the time. And every time we change something in the game, we need to retrain it from scratch, which is not good. It's also a black box and it's hard for balancing. Like, if the designers want to make sure the AI plays a little more that way, it's basically impossible with any modern neural networks. Little more screenshots of the game. Some ornithopters, they're famous in the Dune series. But now for the main part, how did we go at it? Essentially, one of the few concepts I'm going to be going over is the fact that it's data-driven. So we wanted to have basically weights and just numbers that the designers can affect and change, so that, let's say you want this to be more important than this, you can just edit it, and you don't even need to close the game. It just applies real time, and they can just experiment with that. One thing we like to say is, if the AI asks for something once, probably don't listen to it. But if it asks for it 100 times, it's probably important. So then listen to it and do it. That's a representation of like gauges. Like, do you want an X? And it fills up to a point where like, okay, maybe we should try to annex. But it's not going to happen right away. We also have tons of constants, as I mentioned, a few different forms. We either have like a fixed value for something. For example, the more wind you have in a region, the more likely you are to want to annex the village. We also have multiple values. We can either pick one of those or pick a random number in between, which is good for a lot of things. And then the last one with the 4 values, I'm going to get to that part later on. That's one way we use to make the AI play better on harder difficulties. So one thing that is pretty important is the resources in the game. So imagine you want to build 2 different buildings. Like, you can build 2 different buildings, but one of them costs 400 and the other costs 200. If you just leave the AI play without any form of restraints, it's always going to build the one that costs 200 because it's cheaper, so it's going to be available. And since, as I mentioned, the AI checks every second, it's going to be, oh, I can build that. But then you'll never get the one that's 400, but it could be more important. One way we did that is creating reserved resources. So that means some of the buildings or things in the game, actually, like units, anything, can just request to store a certain amount of the resource with a certain priority. You can see that, like, if you're in the FBI and you have like a badge of priority, like 5, you can access every office that is on 5 or lower, but anything that's higher, you can't. Same thing with that. So as you can see, I'm going to show you a quick example. If you have 500 of the resource, the plascrete, the refinery, which is a priority 4, I've actually showed it up there. It's going to think that it has 450 when it's going to ask the system, how much plascrete do I have? Because in the list up there, that's debug information for us, but you can see that priority 5, something decided to store 50 plascrete. Therefore, anything lower is going to think that it doesn't really have them. So if you try to build a refinery, it's going to work, because it thinks it has 450, but it actually costs 400, so that's fine. But if you were to try to build a listening post, which is only priority 1, it's a less important building, if you remove the 350 that are all in priority higher, the AI is going to think that it has only 150, so it's not going to build. So that's one way to prioritize which buildings are important. Talking about cheats, because obviously you could ask the AI to cheat sometimes, like it needs this building, it's important, so just give it to her. Probably a bad idea. A few examples of cheating actually is the very obvious ones, gifting resources or troops or buildings or anything. That's really problematic in my opinion, because if you're a player and you think you've played really well, you try to suffocate the AI and like starve it from resources, but then you still see it play easily by units and do things, you're going to be asking yourself, like, why do I even play the AI if it's just going to do whatever, regardless of what I do? So that's why we didn't want to make it cheat that way. Also, I think, as a side note, if you start working on something and you make it cheat from the start, you're going to build up new systems on top of it which are balanced for the cheat. And if you remove the cheat at some point, it's going to fall apart. You have less obvious cheats, the sneaky ones I call, such as gameplay knowledge that the player wouldn't have. Like the AI could magically know the production of every resource of someone. It could also know what's behind the fog of war, because the information exists, but it's not visible for the player as a gameplay layer. That's something we want to avoid at all costs, I think, because when you're a player and you notice it, it kind of feels bad, because you lose a lot of depth of the game. Like, you're not going to try to hide some resources or some buildings, because you know the AI just knows everything. So the AI in Dune Spice Wars doesn't know about it, unless a player in its position would know about it. And then you have a very hidden one that our AI has to use sometimes, but mostly for just making things easier for ourselves. One quick example of that is if the AI wants to replace a building by another building that's more important, it's actually going to delete it instantly, whereas a player would need to wait like 4 or 5 seconds to delete it. That's almost invisible for the player, but it's just easier for us, so we're fine with that. A few examples of code now. Maybe quick show of hand, who's actually familiar with programming here? Just so I know. Okay. I'm not going to go too much into details, but there are a few things that we use mostly in Haxe and just in the game that I'm pretty proud of, and they're really useful. As you can see, this code right here, it's a function. It's called add-equipment. And the way we did that is we created a macro that's called the API up there. This will actually generate 3 different functions. One that's still called add-equipment, another one that has the prefix can add-equipment, and then another one check add-equipment. And this function actually returns at the end of it something that's called do, which is a reason, with the actual behavior of the function. So like the function add-equipment could work with only the last part. All of the first things are just checks to ensure everything is okay, and like it has resources, it has enough spots, everything is in order. And essentially, what this does is the add equipment, if we call it, it's going to do all the checks. If any of the checks fails, it's going to early exit and return the reason. But if all of the checks succeed, it's going to call the behavior as an RPC, which is a remote procedure call, so on the server, and then return success. But the can add equipment is going to be a little different. It's going to perform the checks locally as well. If it fails, anything fails, it's going to return false. And if it reaches the do at the end, it's going to return true, but it's not actually going to run it. Same thing for the check, except it doesn't return true or false. It returns the actual reason. And that's really useful because for multiple reasons. With that, we can use one single function for everything in the code, for like the UI, for the player, for the AI, anything. If you make a button that's supposed to build the building, you can actually decide if the button is enabled by calling the can add equipment, and if it's false, it's disabled. If you show a tooltip, like we do in those games, because there's a lot of information, in the little tooltip, you can also display why it's disabled by calling the check equipment. So if the check returns missing resources, the tooltip is going to be able to feedback that to the player. And we're making a game that requires a lot of feedback, so that's important. And then the actual function, when you click on the button, is going to be run on the server, so you avoid cheating. Server has authority and decides everything. And one good thing, because I'm still talking about the AI, is that we only need to make the function once, and it works both for the AI and for the players. So that's also good for us, reduce time. You might have seen in the previous slide that we return a reason, and that's really useful because we created an enumeration in Haxe that's all of the reasons that can happen. We have a ton more on the database that are simpler, but you can also have context in the Haxe enumeration, and I wanted to talk about that briefly because I don't think I've seen it in another language yet. Essentially, you can put parameters in the enumeration so that you can store context. In this case, if you put your mouse on one of the buttons that's grayed out, it's going to tell you, no, you can't actually build this building because it requires economic lobbying, and economic lobbying is actually a tech tree, like a tech that you can research. But if you haven't yet, the function is going to return the reason, which is require unlock, the one with the arrow. And if it does, we know how to feedback it to the player, and we can also only translate all of those just once, which is good as well, and make it like a dynamic display, which once again are all those little tricks that we need to use in order to make games that are that big with a very small team. So these are pretty nifty. Now the real-time aspect, maybe it's kind of vague for some of you, but when I say real-time, I mean that it's not turn-based. So the AI actually needs to know every second what's happening around the territory, you could say. So we made a scoring approach to almost everything in the game. So the AI is able to score any object or concept at any time. For that, obviously, we need to tell it how to score it, of course, but we only do that once. And as you can see, I've scored right now annexation. So if I ask the AI, how good is this village, if you wanted to capture it, it's going to give you a score about all the villages. And that's used for like everything. How good is a tech, how good is a village, how good is a unit, and we can put as many different factors as we want, which is really useful. So how do we use it? It's pretty simple as well, again. We have a function called scoring with the name of what we want to score, and we just pass in a bunch of stuff we want to score. For example, in the previous screenshot you saw, we would just call it the function like building or village, with all of the villages that are available. So maybe every village that we've discovered, but not ours, because we can't capture something that's already ours. We give it all that list, and then it returns a map of the lists of each element with its score. And then we do a weighted pick. That means if something has a score of 100 and something has a score of 10, the 100 is 10 times more likely to be picked. Among the X best elements, I've intentionally put X because I'm going to explain how we find that value as well. And one thing I wanted to mention with the language this time, once again, a really useful feature of the Haxe language is that you can see at the end the pick map weight, the function. It's actually an extension. It's a little piece of code that we can write. You just need to put the first parameter as the type you want to extend, and then you use the file with the keyword using somewhere else, and it just becomes an extension of that type. And you can do that on any type virtually. So you can even extend like integer or whatever, and everything works. So pick map weight, as you can see, is called directly on the map that the function returns. So it really makes the syntax a lot simpler and easier to read. And I wanted to talk about how we manage difficulty. Obviously, higher difficulty means more resources, even though we try to be careful with that, but they do get a little bonuses in productions and everything. We also plan on showing that to the player, it's not hidden. But there is also one way we found to make the AI play better in higher difficulties. Essentially, when you've seen that it can score, for example, 50 different villages, and then it's going to pick a random one out of the best ones, but that value, the best ones, is going to be smaller and smaller in higher difficulties. That means that an easy AI has a chance to pick something that's not so great. It's still good. It's a good village, but it's not the best. And then the insane AI is going to pick maybe between the two best. So you still have random. It's not too predictable. It's not easy to know what it's going to do when you play against it. But it's just generally going to make better choices at everything, which usually results in a better run. So that's the function. That's the parameter you've seen in the last slide. We have like this little helper function that's called getAIValue. We give the constant and the AI. And then as you've seen the early slide that was saying the constants, and you can have like 4 values, or it's going to pick the right one depending on the difficulty. And once again, that's really useful because even if we change the difficulty during the game, just for test, whatever, all of this works real time because the database is always queried when we need it. It's not like saved or anything. So the AI is really simple to debug and experiment around. That's an example of that. As you can see, the smugglers, they're on normal difficulty with the little arrow. So they pick between the 4 best villages. So there is a chance that it's going to capture the one over there that has a score of 3, which is not great, but it's not completely useless. But if you put it in insane mode, it's only going to pick between those 2, which ensures that the AI plays better over time. Let's talk about scoring some more, because as I've mentioned, we score a lot of things. We have this system called AI weights. It's very simple. Basically, we have 3 criteria, which is the type of the AI, the faction, and what counselors you use. Counselor is, you can pick 2 each game. You have a total of 4. It's like advisors, and they give you little bonuses and passives. They change the game style. Some counselors are like oriented towards military play, others are more economic and everything. So how do we use that in the game for the AI? Essentially, all of those lines are going to be added together. If one line is valid for the AI, it's going to be added. That means, for a little example, if the AI is on Atreides, the green faction, it's playing economically, and the 2 counselors that it has are Jessica and Duncan. The total score is going to be 50, because line number 0 then is going to be valid. It's economy. Line number 3, and I've made a typo because it's 30, not 20, but you get the idea. Line number 3 is going to be valid as well because it's economy, Atreides, Jessica, and the last line is going to be valid as well because it's Atreides. So you get a total of 60 and not 50. But if you were to be an AI that plays Corino military with Fenring and Wencistia, you're only going to get a score of 5, which is line number 1 because it's Corino. But as you can see, even though it has military on line number 2, it doesn't actually have the right counselor. It says Yakin, which is not a Corino counselor. So you're not going to get that score. And that's pretty useful. Once again, like the designers can change that anytime they want, which is really good to experiment with the balancing and the choices it makes. There you go. Now, as I've mentioned a few times already, the AI is real time. Well, it plays the game that's real time. And it makes a lot of decisions every second. So it's kind of hard sometimes to know why it did something or what it's trying to do right now. That's why we need to be making a lot of visualization tools. That's one example, but the next few slides are going to be examples of some of the tools we made. Essentially, if we wanted to be going on the equipment system and we want to know what the AI thinks of this unit at this moment, you can equip certain special equipments on units. The lists of 5 equipments are displayed with the corresponding scores, which is really useful because you don't want to be doing the calculations in your head or in paper all the time. That's the window for equipments. So we know what the AI thinks of each equipment for each unit, which is useful. Otherwise, we have no idea why it decided to go for this. That's the research window. Same thing, we display little red line that says the score and the position in which it's going to be researched. So if we didn't do that, like we would have no way of knowing why it went that way or which was first or what's coming next. That's for the military decisions. That's a big thing. I'm not going to get into the details, but as you can see the path, you have like those yellow, red, and blue lines. That's how the AI decides to take some units and make them go from point A to point B. Blue is shuttle, because you can take those little ships to go faster. Red is walking, yellow is walking as well, but before they can start a yellow line, they need to wait for each other. They need to synchronize somehow. So we can visualize what they're doing real time, and then you also have the feedback with the order system. You know what they want to do when they go to the village, if they want to annex it, pillage it, whatever. And you know in what phase of the order they're in. So we know real time everything. That's also the micro decisions. So we have a little minimalistic engine for deciding how to micro units, and we display it with like circles of what role are you in, who are you targeting. If we didn't do that, it would be really difficult to balance it, I think. In conclusion, the AI, we went at it not really knowing what we wanted to do, aside from the few things I've mentioned, like we don't want it to cheat, we want it to be easy to maintain, but we didn't have a clear plan on, okay, we're going to architecture all of that for the next year. And I think that's important because when you look at complex systems and big games or big systems, an easy mistake to make is to actually go and over-architecture it, like over-engineer things. Just because you know it's a very complex thing, you're going to be telling yourself, oh, I need to make a super complex system so that it handles everything. But it's actually not true. We actually realized that it's much better to take it a few steps at a time, go gameplay first. You just make it simple, make it work, and then you can build on top of it. And maybe 20% of the time you're going to end up throwing code away and rewriting a different way because you know the context has changed, but that's fine because 80% of the time it's going to do the work just fine and you didn't waste any time doing something extra complicated. So I think that's really important because we tend to do that in games. What's good about the AI we created is, as I've mentioned, you can drop it in any game on any faction at any time and it's going to be able to play. So we actually use it when players disconnect from the game. We let the AI take over and it works just as if it was playing from the start. So that's pretty good as well. And all of the scoring and the random that we've added makes it so that it's not too predictable, which is always funny because you can see on the Discord some players just screenshot something and be like, oh, the AI decided to attack me here. That's pretty much because I've done that and I've done that. And I know because I've created it. I'm like, that's not at all why, but it's funny that you think that. And it's a good thing. If players can interpret things their own way and it's fun for them, that means we kind of succeeded. So that's one big thing about it. It's not predictable. Problems are, still needs somewhat lot of maintenance. Mostly, I've mentioned the scoring and everything. If the designers decide to change a building or change a unit or anything in the game, and no one takes the time to actually change or edit all of those weights, all of those decisions, progressively over time, it's going to start playing worse and worse because we don't update it. It doesn't seem too realistic, at least for our game and the way we do things, to have like a perfectly generic AI that's able to react to anything because we have like a lot of gameplay systems that don't really allow for that. But we still need to update it. It's okay. It doesn't take too much time. It's just making the effort to do it. Some victories are a little harder to achieve. As I've mentioned, it's fully reactive and not proactive. And some of the game victories, one I could mention is like the spying victory. You can assassinate opponents. Is going to be pretty difficult to achieve with this AI because it's not going to set up all of the necessary pieces easily because it knows in advance that it's going to try to assassinate. Rather, it's going to assassinate if all of the pieces are like put in place. So that's really hard to steer and make happen without forcing it. And if we start forcing it, we kind of ruin the entire system we created. So sometimes it's complicated, but there's like a line to find between never forcing it doing anything and forcing it on everything. You can make some stuff being predictable, just to let the rest take care of itself. That's my last line. So I've already talked about a few of those things, but another thing is explore options. Why did I say that? It's because we didn't have like a pre-made model before we started where someone had like 15 years of experience and was like, oh, we're going to make it work that way and it's going to be perfect. No, it was more like we had an idea, we tried it, made it really simple and quick, seemed like it was working, and then the system evolved with time and with the game. And I think that's the biggest part of being a gameplay programmer is usually you want your ideas to be simple enough so that you can test them really quickly, rather than creating a super perfect system for 6 months and then you realize the game has changed and your system is sort of obsolete. And always think about the game. Yeah, that's pretty much it. Like it's good to try to plan ahead and be like, maybe in 6 months they're going to need this or that. But the main thing is, if you only do about like what you need to do for the game, it's usually going to be enough, and then you can easily add the rest. That's the thing about it. And if it really doesn't work, just I guess nuke the code and start over. So that's a pretty cool effect, special effect from the game, from the nuke of the game. And that's about it for me. Thank you for listening. If you have any questions, I'll be happy to try and answer it.
Hello. First of all, I want to thank you for this presentation. It was very interesting and I learned a lot of things. I wanted to ask something about game design. Since you said that your AI can be modified partially by game designers, if I understand correctly.
Yeah, that's it.
Which aspects are done by the programmers and which aspects can the game designers change?
Yeah, good question. So essentially, when I was talking about the scoring, how we score things. So let's say you have this concept of wind in the game. You can have a score of wind in the regions. It's the programmer's job to tell the code for each wind, add this score. That's specific. We have to write it once. But then how much we add per wind is going to be up to the designers to change as they go. Because this thing alone doesn't really make sense, but then if you have like 15 other things that are scored, the programmer writes all of those 15 things and how we score them and all the behavior, but then it just requires some tweaking in the database to like see the final impact of all those 15 things together. But the programmer needs to write it once, basically, and sometimes update it as the game goes.
Yeah, thank you for the presentation. You just mentioned that you spent a lot of time visualizing what the AI does. Did you had at some point of time to compute the whole resolution of several matches and games just to make statistics and realize, okay, this AI and those parameters are too much? Did you spend some time doing such research?
Yeah, yeah. It's interesting actually because letting 4 AIs play together and watching them play, and that's mostly how I decide to debug the system. And like judge, is it playing well? I just start 4 AIs, random types, random counselors, random everything, and let them play and see what happens. That's specific for AI, but that's one thing I had to learn, is that sometimes one of the 4 AIs is going to be completely out of the game. It's going to play terribly. But sometimes that's just because the other 3 are playing really well, and it's normal that there's a loser in the game and a winner. So I had to like stop myself sometimes and stop trying to fix something that wasn't actually broken. So I was asking myself, why did it play poorly? Should it have gone in a different regions? Should it have done that differently? But in reality, the answer was no. It was doing what it should be. But other AIs were also doing what they should be, and they got the upper hand. But we did have to, like, I do spend a lot of time just watching 4 AIs play and tweaking things, seeing problems, bugs, and things that shouldn't happen that way, or things that I thought I did differently, and they're still doing that, and it's not okay. Yeah, it's a lot of time used on that.
Hello, thank you for the presentation. I have a question that came to me when you showed us the tracks, the red and yellow tracks. And so I imagine that if the units wait for each other, you make groups of the units, especially when there are many units, when the game is advanced. And I was wondering how the AI managed to decide when to split groups, make this unit go to another group. They need units at different places. And
yeah, that's a really good question. The full answer would take a whole different presentation, I guess. But in short, we decided not to make it too complicated. Essentially, if it tries to, let's say, capture this village, it's going to just look at all of the units one by one from closest to furthest. And it's going to go, okay, I think this unit has this much power. It's an estimation. It's not perfect, but it's like we estimate the power. What we want to attack has probably this much power. And we just add units until we reach enough power so that we know the attack is going to be mostly successful. Against neutral enemies on the map, it's very easy. Against players, it's always harder because we need to take into account that they could defend themselves and stuff. So there's no real squads or way to make them move together for certain reasons. It just happens organically because when we want to make something happen militarily, we're going to take as many units as needed, group them together in like form like some rally points, and then send them together to the thing, and anyone that's still surviving after it is going to retreat to the closest village, and they're still going to be next to each other. But it's not like intentional. It's not something we make them do for now. Like we don't have predetermined squadrons of we need 1 melee, 1 tank, 1 supporting unit, and this is going to be this squadron. It's purely organic, basically, with like slight exceptions such as we usually want a melee unit to attack because range units get like a penalty when they get pinned down by a melee unit. Aside from having 1 melee unit for most things, we don't really do hard-coded stuff. Kind of let it do its thing. But once again, that's interesting because the reason it's going to most likely have the right units for it is because we also score the units. So we also score how the AI is going to buy units. And one of the things that we did was called the excess weight. So if you already have a unit of type A, it's going to remove the excess weight for buying another unit of type A. And if you have 5 of them, you're going to remove it 5 times. So the more you remove score, the less likely you're to buy another unit of that type, which usually leads to kind of like balanced rosters of units, and so like a bit of everything. Thank you.
Thank you for the presentation. I was wondering, do you usually choose the data, or do the designers do?
Yeah. So I suppose that usually depends on the studio size, probably. Shiro Games is quite small. The team working on Dune is like, it varies, but it's like 10 to 15 people. How we work is I'm going to set up the whole thing, tell it how to score. Sometimes I'm going to talk to the designers about how to approach things, but mostly I'm going to be making the system. Usually I'll make it so that every value has a value that makes sense. Like it's going to be able to play. It's going to do pretty well and okay. But then they can go over it and decide to tweak stuff, change stuff. But like the main part of it is done by me. Like I don't just set everything to 0 and send it their way and be like, now you can use that system. The way we work is, even though they're designers, they just want to open up the game and see that it already works, and then they can change stuff as they want. But I'm still making like the system work from the get-go. Yeah.
Thank you.
Hello, thanks for the presentation again. So you said your AI don't cheat. So did you emulate some errors that you can have if you don't look at the all of your territory and all of the maps? And how did you manage the? I didn't understand well if you said you don't think about fog of war, or if you take it in considerations. So how did you manage that in the AI way?
Yeah. So they don't see anything that's in the fog of war. They only see what's available. Like if you're a player and you've discovered that region, they're only going to see that. And we had a problem initially. For an example, there's a resource in the game called Authority. That's the resource that you use to capture villages. And we had a problem where every time it would just use the Authority to capture the first village it reconned, just because it could. And we weren't happy about that. So what we kind of had to find like clever ways to force it to wait somehow, but not like a fixed way. We made it so that if there's like 5 possible villages, and the 3 best are these 3, and out of all of those, the one you want is actually too expensive. We're gonna make like a delay of, well, maybe you should be waiting a little, but then next second is gonna try again, and at some point it's gonna reduce the waiting. But if we always land on something we can't buy, we're gonna keep adding, and at some point we're gonna have enough for everything, and it's gonna reach 0, and the next choice we make is gonna be the 1. So that's one way we kind of guarantee that we don't always take the first thing that happens. And so why I'm saying this is because sometimes we had a problem where there was like this amazing territory, the best possible they could ask for, but it was right next to another one, but it wasn't discovered yet. And it would just shoot itself in the foot by taking all 3 other territories that were discovered before taking that one. But instead of making it cheat and go, oh, you know what's in there, you should wait for it, we kind of had to like find ways to make it play smart and delay some actions. One of those things is the reserved resources I've mentioned. That's one way to delay some actions for more important ones. But yeah, there's like a few tricks like that to ensure that it doesn't just always take the first thing and shoot itself on the foot, as I said. But yeah, it actually doesn't need to look at hidden data. It's only basing its opinion out of what's available right now.
I have a question. So do you use playtests for improving your EA, or it's not, you don't see the necessity to do it?
We do some playtests, but they're more generic. Like we ask players to play the game, either in single player or multiplayer, and give us feedback on everything, not just the AI, so like the gameplay, everything, the new systems. So we do get some feedback on the AI, valuable feedback that's interesting, but a lot of it is me and probably one of the designers working with me at the time, just starting a game. either with 4 AIs playing each other or you playing against 3 AIs and judging, is it performing well? We don't have like a 15 people ready to just look at the AI and analyze it that way. It's mostly just us and making sure the AI plays well. I've mentioned it at the start, but we don't actually want to make the perfect AI. We just want to make an AI that plays relatively well and is fun for the player. That was the initial goal. So as long as it's doing okay, we don't need it to make the perfect choice every time. That's why there's a lot of random into it, and yeah. So little playtest, but not too much.
Because you can have some bias on your own way to thinking, and it can be fun to add some other strategy you maybe didn't think about in AI, but it can cost a lot. So
yeah, no, you're right. I've had that problem before where I was working on some of the ways the AI could play the game, and I realized that I was trying to make it play the way I play the game. So you have different types of players. You have like those that are super aggressive all the time. You have people that like to make the best possible villages and generate tons of money. And I realized that I was sometimes making it play the way I wanted to play the game. So that's also why we have a few people just coming over, giving feedback on what it's doing, what it could be doing better, what's doing well already. But yeah, definitely the not making it in your image is important and takes a little bit of effort to consciously, you know, take a step back and be like, okay, maybe this is not the way it should be, and yeah, ask for feedback, ask people. Communication within the team is really important, and I think at Shiro Games that's one of the great things is that since we have small teams, we're able to talk to each other every day. I talk to designers every day basically, and we try to make the game step by step, thinking about the gameplay and making, like, you know, gameplay first changes usually. And that's one of the reasons it's easy to go and ask someone, hey, can you play test the game and see if the AI works well or whatever.
So no question. So we will end, and the next conference will start in 10 minutes, I guess.
Well, thank you for being here.